Now we want to turn our attention to some special products in algebra. We want to look at, first of all, the square of a binomial. So here I have x plus 3 quantity squared. The most common mistake I see students make is to write this as x squared plus 9. This 2 means that this base has to be written as a factor twice. So it's x plus 3 times x plus 3. Now I'll multiply using the FOIL method or whatever method I want, but each term here times each term here. X times x, x squared. X times 3, 3x. 3 times x, 3x. And 3 times 3, 9. So you can see you don't get just x squared plus 9, you get x squared plus 6x plus 9. So that's the product x plus 3 times x plus 3, x squared plus 6x plus 9. Now you'll notice in the book we have a formula for this too that looks like this. A plus b quantity squared will always come out to be a squared plus 2ab plus b squared. So this 2ab is this middle term 6x, and it comes from multiplying a times b, the first term and the second term, and then doubling it. So if I multiplied x times 3, I would get 6x. Oops, x times 3, I'd get 3x. I doubled that and end up with 6x. So that's that middle term. Let's see if we can apply this formula to this expression right here. So let's move the camera up just a little bit, get this formula back in right here. There we go. So what the formula says is a plus b quantity squared is the square of a, so I'll square this, 9a squared. The square of b, that is the second term, so I'll square this, 25b squared. And then the middle term right here is twice the product of these two terms. So 3a times 5b is 15ab, doubled is 30ab. Now, if you want, you can simply multiply this out by writing this as 3a plus 5b times 3a plus 5b and going through the whole regular long multiplication process. You'll get exactly this. But if you've got this formula memorized right here, you can use the formula and get to the answer just a little bit quicker. Our next problem involves a couple of special binomials, x minus 3 times x plus 3. If I multiply x times x, I get x squared. X times 3, I get 3x. Negative 3 times x, I get minus 3x. And negative 3 times positive 3, I get negative 9. This comes out x squared plus 0x minus 9. So I end up with just x squared minus 9, and that's a special product, and I have a formula for it. Anytime I multiply a minus b times a plus b, the result will always be a squared minus b squared, and this result is called the difference of two squares. Let's see if we can apply this formula to this expression right here. 6 minus 7x times 6 plus 7x right here, so I see that this binomial times this binomial has this form to it. So since it has that form, I can just simply write the answer as 6 squared, which is 36, minus 7x quantity squared, which is 49x squared. So products in this form right here always result in the difference of two squares. These two binomials have this form to them, so that product results in the difference of two squares also.